So using a commercial space-based internet system architecture, we modeled an attack on a space vehicle from an ex-employee's phishing attack, which propagated through the user segments into the ground segment and finally disrupted a space vehicle. So we utilized the MITRE ATT&CK and Sparta frameworks to create our attack and defense tree model. And in the initial attack, the adversary sends an email posing as the help desk boss and sends this email to attempt to create a log of emails and passwords of everyone that currently works at the ground segment control center. So this gave the attacker stolen login credentials required to access internal web portals, enumerate the user segment network, and achieve his goal of gaining access to ground segment control center network. He was also able to access the system administrator dashboard or panel after utilizing these stolen credentials, and he was able to change the password for the current system administrator and also change configuration settings as an ancillary attack to his main goal. So once the adversary is on the ground segment, the attacker here, or the adversary, conducts reconnaissance to enumerate and map the ground segment network. Once completed, he crafts spear phishing emails, malware, and nefarious email attachments needed to achieve freedom of movement throughout the ground segment control center network. After weaponization and delivery are complete, the exploitation phase will use drive-by downloads, intranet web portals, and remote services to gain initial access to the ground segment and any industrial control system network systems. Finally, we have persistence, which is achieved during the maintain phase in the network through backdoors, PLC modifications, and account manipulation. After achieving persistence, the adversary resumes reconnaissance phase operations to continue moving through the network and discover new devices, achieving his goal of establishing persistence on the ICS ground station. The attacker then uses social engineering to gather information about a target space vehicle and mount an attack on the space vehicle that disrupts its utility. In addition to social engineering, the adversary can also use space sensors in different ways to get information on the target spacecraft's trajectory and utility. From here, the adversary picks a particular proximity-based attack, and there are different types of attacks, such as going close by to monitor some of the traffic, or if that target spacecraft is fully solar paneled, there can be an attack where the adversary is not too close by to the target space vehicle, but the adversary can cast a shadow on the spacecraft's solar panels to slowly disrupt the utility of the space asset, making it power down for 2 days or, for example, 2 very important days. So the attacker collects this information, deploys a particular adversarial spacecraft which does this, and the adversary also adds randomness to achieve plausible deniability so no one can frame the adversary for these attacks. So to defend the user and ground segment networks, network and host-based intrusion detection or prevention systems will be installed to scan and remove malicious traffic using anomaly and signature detection. Network segmentation will bifurcate and isolate operational networks and systems as reconnaissance and pivoting defenses. Firewalls and access controls will ensure confidentiality by blocking unauthorized access to networks and file systems. Training users on the dangers of social engineering and recognizing indicators of spoofed emails will also add layers of defenses to our plan. Email encryption, server-side and client-side email defenses will help mitigate threats from email-based attacks. Robust data recovery backups, coupled with separation of duties, least privilege, and restricting access to security directories, will safeguard the availability and resiliency of operational information. Space vehicle defenses will be enhanced with our pre-launch behavioral expectation establishment protocol, establish proximity, delta path tracing, solar shielding, and signal jamming. We should focus here on making the protocols composable with high utility and established a trial committee if harmful. Lastly, we shall support the trial committee with information escrow for all launched spacecrafts.